So this is the altar stone. The big question is how on earth it was transported from northeast Scotland.
Some of Earth's most breathtaking landscapes hold remarkable secrets older than civilization itself. From the surreal Rainbow Mountains' vibrant, otherworldly colors to the enigmatic Great Unconformity, a staggering, mysterious gap in geological time.
I've travelled around the world to see some of the most amazing geology, but this place just tops it all.
These wonders provoke sensation and ignite curiosity, challenging everything we thought we knew about our planet's history. Stay with us as we count down 20 ancient geological wonders that still baffle scientists. Richet structure. In the vast expanse of the Sahara Desert lies a geological formation that defies easy explanation. The Richet structure. Spanning about 25 miles, this enormous circular feature stands out sharply against the endless sand, visible even from space. Despite decades of research, its true origin remains uncertain, making it one of Earth's most intriguing natural puzzles. Initially, many suspected the formation was the result of a meteor impact, given its perfect circular shape. However, thorough investigations found no evidence of an impact crater. Instead, the Richet structure is understood as a deeply eroded geological dome. Over millions of years, layers of rock that were once pushed upward have been gradually worn away, revealing rings of rock with different hardness levels. These differences in erosion rates sculpt the distinct concentric rings that give the structure its signature bullseye appearance. The Richet's rock composition includes sandstone, quartzite, and limestone, each weathering at its own pace. The dome likely formed due to geological uplift, potentially from volcanic forces or a rising salt dome beneath the surface, though no single explanation has been confirmed. Adding to its mystery, fossil discoveries in the area reveal that the region was once underwater, part of an ancient ocean that shaped the environment long before the desert existed. Its impressive scale and complex formation continue to attract scientists and explorers, all searching for the full story behind this remarkable natural feature. Great Unconformity. Every rock layer tells a story, but some chapters are missing. The Great Unconformity is one of the most striking examples of that. A vast gap in Earth's geological record where hundreds of millions to nearly 1 billion years of history have vanished. You can see this gap clearly in places like the Grand Canyon, where very old, ancient rocks sit directly underneath much younger layers with no middle ground. It's a massive break in the rock record that puzzles scientists and reveals just how dynamic and sometimes destructive Earth's surface can be. What happened during that lost time? The answer lies in powerful natural forces reshaping the planet. Over long stretches, erosion stripped away layers of rock, removing evidence of entire eras. Ice ages may have played a role, with glaciers grinding down mountains and plains, or tectonic activity might have caused upheaval that exposed and erased older rocks. This combination of erosion, mountain building, and other geological events essentially erased huge chunks of Earth's surface, leaving the Great Unconformity as a witness to those processes. The significance of this gap goes beyond missing rocks. It marks a key turning point in Earth's history, linking geological and biological events. Understanding when and why these rocks disappeared helps scientists connect the dots between shifts in climate, the rise of life, and major environmental changes. The Great Unconformity challenges researchers to rethink how the Earth evolved and highlights the constant, often violent, cycles shaping the planet. Cave of the Crystals. Now and then, nature creates something so extraordinary it feels almost otherworldly. The Cave of the Crystals in Naka, Mexico, is one of those places. Deep underground, in the heart of an old mine, lie some of the largest natural crystals ever discovered. These gypsum crystals reach lengths up to 36 feet, making them unlike anything found anywhere else on Earth. This isn't just a cave, it's a stunning natural archive that tells a story of extreme conditions and slow, precise growth over hundreds of thousands of years. The environment inside the cave is harsh. Temperatures soar above 130 degrees Fahrenheit with humidity close to 100%. Such conditions are deadly for humans, but perfect for crystals to form and grow uninterrupted for centuries. This extraordinary setting results from unique geology and hydrothermal fluids rich in minerals seeping through fractures in the rock. Over time, these fluids deposited layers of crystalline gypsum, slowly building the enormous structures seen today. The Cave of the Crystals is a window into mineral formation processes that normally take millions of years, condensed into a spectacular display. Scientists continue to study the cave not only to understand crystal growth, but also to explore how life might survive in extreme environments. The fragile beauty and sheer scale of the crystals make the cave a rare natural wonder, one that demands careful preservation. While mining activity threatens the cave's stability, researchers hope to protect it as a valuable scientific resource and a remarkable example of Earth's geological creativity. Yonaguni Monument. Although this monument lies submerged nearly 80 feet beneath the ocean's surface near Japan's Yonaguni Island, its origin remains a subject of intense debate. This underwater formation exhibits large terraces, sharp edges, and step-like features that have drawn attention for decades. Its unusual appearance raises questions. Is it a natural geological formation shaped by Earth's forces, or the remnants of a man-made structure from a lost civilization? Geologists studying the area emphasize that the rock composing the monument, mainly sandstone and mudstone, is prone to fracturing along straight lines. Over thousands of years, tectonic shifts combined with natural erosion could produce the monument's blocky, angular features. This explanation suggests the striking shapes are a result of natural processes rather than human craftsmanship. The region's history of seismic activity further supports the possibility that these shapes were formed without human intervention. On the other hand, some researchers argue the monument's symmetry and precise angles are too regular to be purely natural. They suggest ancient humans may have shaped or enhanced the formation before rising sea levels submerged the area. This hypothesis opens the door to speculation about prehistoric civilizations and their engineering capabilities, though definitive archaeological evidence remains elusive. The Yonaguni Monument continues to intrigue both scientists and divers, standing as a compelling example of the blurred lines between nature and history. Whether it is an underwater geological oddity or the ruins of a forgotten culture, the monument underscores how much of Earth's past remains hidden beneath the waves, waiting to be discovered. Altar Stone. You might not realize it, but the altar stone at Stonehenge carries a story that stretches hundreds of miles across ancient Britain. This enormous stone wasn't gathered from nearby. It was transported more than 250 miles from the Scottish Highlands all the way down to southern England. Without any modern machinery, ancient people managed to move this massive rock across challenging landscapes, including mountains, rivers, and forests. The scale of this effort reveals just how sophisticated and determined these communities were. The stone's unique origin challenges previous ideas about Stonehenge's construction and the connections between ancient groups. Transporting a single heavy stone over such a distance required careful planning, coordination, and probably a lot of people working together. Scholars wonder if waterways helped ease the journey or if there were routes specifically made for hauling these massive stones. The effort involved suggests the altar stone held great importance, likely tied to religious or ceremonial functions, setting it apart from the other stones at the site. What makes the altar stone especially intriguing is its distinct type of rock, different from the surrounding stones at Stonehenge. This difference hints at a special purpose, perhaps as a focal point for rituals or symbolic meanings lost to time. Its transportation and placement were no accident but deliberate actions loaded with significance. Egg-laying Mountain. Keep your attention focused on one of China's most unusual geological features, Egg-laying Mountain. This striking cliff face is covered with hundreds of rounded boulders that resemble giant eggs resting against the rock wall. Their smooth, almost perfect shapes set them apart from typical mountain formations, creating a landscape that has puzzled scientists and visitors alike. Unlike ordinary cliffs, this formation looks like a collection of massive stones deliberately placed, but the truth lies in natural processes. These eggs form through spheroidal weathering, a type of erosion where water seeps into fractures and gradually wears down rock layers from all sides, rounding their edges over time. This process, occurring over millions of years, peels away the outer layers of rock much like an onion, resulting in the distinctive rounded shapes. While local stories and some explorers have suggested alternative, more mysterious origins, geologists agree that natural erosion is responsible. The formation's scale and detail make it a rare natural phenomenon, demonstrating the power of geological forces to shape unique and eye-catching landscapes. This mountain is a testament to the slow but relentless work of natural erosion. It encourages us to pay closer attention to the landscapes around us, where even simple rocks can tell complex stories shaped over millions of years. Underwater Lost City. Every time new underwater formations are discovered, they challenge our understanding of Earth's history. Near Zakynthos, Greece, divers encountered a striking underwater site that many initially called a lost city. Its sharp edges, flat surfaces, and block-like shapes led to speculation about ancient human construction beneath the waves. However, further study revealed this site is not man-made, but a product of natural geological forces. The formation is shaped by tectonic activity, where shifts in the Earth's crust caused fractures and cracks in the rock. Over thousands of years, erosion and sediment movement sculpted these fractures into shapes that resemble architectural ruins. The underwater environment further accentuated these features, creating an illusion of straight lines and terraces. These natural processes combine to form what looks like a submerged city, but it is purely a geological phenomenon. While the idea of a sunken civilization is compelling, science points to the power of Earth's physical forces in shaping landscapes, even underwater. This formation near Zakynthos serves as a reminder that nature can create patterns that trick the eye and spark stories. The lost city near Zakynthos is a fascinating example of how natural processes can mimic human-made structures. It shows that sometimes the most surprising places are not the result of history, but of geology's ongoing work beneath the surface. This discovery keeps geologists and explorers intrigued, pushing the boundaries of what we know about Earth's underwater landscapes. Rainbow Mountain. Nothing compares to the vibrant display of colors on Rainbow Mountain in Peru, a striking example of geological processes in action. Located high in the Andes at more than 17,000 feet, this mountain showcases bands of reds, oranges, yellows, greens, and purples, all created by layers of minerals laid down and exposed over millions of years. Each color corresponds to specific minerals. Iron oxide produces reds, chloride accounts for greens, and sulfur compounds give yellows their shade. The formation of Rainbow Mountain involves a complex history of tectonic activity and erosion. Over time, sediment layers rich in different minerals were pushed upward by the movement of Earth's crust. Then, glaciers, rain, and wind gradually wore away the surface rocks, exposing the colorful layers beneath. This process reveals not only the mountain's mineral makeup, but also a record of environmental changes over vast stretches of time. These days, Rainbow Mountain is a popular destination for hikers and travelers drawn to its striking appearance and the story it tells about Earth's geological past. Its colors serve as a natural archive, reflecting shifts in climate, sedimentation, and tectonic forces. Beyond its aesthetic appeal, the mountain offers insight into the powerful forces shaping the planet's surface. The wave. This one stands out as a remarkable natural formation in the American Southwest. The Wave in Arizona. It's a sandstone ridge known for its smooth, sweeping curves and vivid bands of color that stretch across its surface. The wave's patterns didn't form overnight. Instead, they developed over millions of years as layers of sand were buried and compressed into Navajo sandstone. Then, wind and water slowly wore away the rock, sculpting the unique ridges and swirls visible today. The striking colors come from minerals like iron oxide, which settled unevenly throughout the layers, giving the rock its reds, pinks, and oranges. This variation in mineral content, combined with erosion, creates the flowing patterns that have made the wave famous. Its delicate structure means it's highly susceptible to damage, which is why access is strictly limited to protect the site from erosion caused by too many visitors. The wave is a prime example of how slow, natural forces can produce landscapes that look almost designed. It's a testament to geological time and processes that shape the Earth's surface in unexpected ways. The formation attracts hikers, photographers, and geologists alike, all drawn by its distinctive beauty and the story it tells about the region's past. Whether viewed as a natural work of art or a product of millions of years of erosion, the wave continues to capture attention and curiosity. It remains one of the Southwest's most iconic geological features, demonstrating the power of time and the elements to create something truly exceptional. Fly geyser. Unlike typical geysers formed entirely by natural processes, Fly Geyser came into existence due to human activity in 1964 when a well drilled into a geothermal aquifer unexpectedly released hot water to the surface. Over time, this water, rich in minerals like calcium carbonate and silica, built up terraces and cones that now glow with vivid reds, greens, and oranges. The geyser's bright hues aren't just from minerals, they're enhanced by thermophilic algae, microorganisms that thrive in the extreme heat of the water. These algae give the geyser its neon colors, making it look like a living, breathing geological sculpture. As minerals continue to deposit, the formation slowly grows, changing shape and size, maintaining its otherworldly appearance. Fly Geyser is a rare example of how human intervention can accidentally trigger geological phenomena that mimic natural wonders. Its existence is a blend of human action and natural geothermal forces, combining to create something unique and continuously evolving. This mix sets it apart from purely natural geysers and makes it a compelling subject for scientists and visitors alike. Whether viewed as a geological accident or an unusual natural feature, Fly Geyser challenges our ideas about how landscapes form. It shows how even mistakes can lead to remarkable, lasting creations that capture attention and curiosity.
And now, it's time for the open discussion.
When we talk about the most mysterious rock formations left behind by Earth's ancient past, this stunning cliffside marvel steals the show. A massive golden block hovers on a tiny rock base, overlooking endless horizons. What natural forces sculpted this masterpiece? How long has it stood there watching over the land, and what stories does it hold? What's your wildest guess about its origin? Drop your thoughts below, and don't forget to mention #OpenDiscussion. Marble Caves. For those interested in extraordinary natural formations, the Marble Caves of Chile offer a unique glimpse into geological processes at work. Located on the shores of General Carrera Lake in Patagonia, these caves have been shaped over thousands of years by the slow erosion of solid marble by water. The lake's waves have gradually carved out smooth tunnels and rounded chambers within the marble, revealing swirling patterns of blues, whites, and grays that create a striking visual effect. The key to the cave's distinctive appearance lies in the interaction between the marble and the crystal-clear turquoise waters of the lake. Light reflecting off the water illuminates the cave walls, enhancing the natural colors and making the interiors glow with a shimmering quality. Seasonal changes and fluctuating water levels alter the cave's look, ensuring that each visit presents a different experience and visual display. These formations illustrate the power of persistent natural forces working quietly over long periods. The cave's polished surfaces and intricate shapes result from a delicate balance of erosion and mineral composition. Their remote location has helped preserve them, maintaining their pristine condition and mystery. Their beauty and uniqueness continue to attract scientists and travelers who seek to understand and witness the outcomes of these natural forces. Pamukkale. Does the sight of brilliant white terraces cascading down a hillside capture your attention? That's exactly what you get at Pamukkale in Turkey, a remarkable natural formation known for its striking snow-like appearance. The name Pamukkale translates to Cotton Castle, a fitting description for the bright, chalky terraces created over thousands of years by mineral-rich hot springs. These terraces, filled with warm calcium carbonate-laden water, have built up layer by layer to form pools that look like giant steps made of white stone. The process behind Pamukkale's creation is both slow and steady. As hot spring water flows down the slopes, it cools and deposits minerals that harden into thick travertine terraces. These formations continue to grow and change with the ongoing flow of water, making the landscape a dynamic, ever-evolving natural wonder. The pools formed by these terraces are not only visually stunning, but have been valued for their therapeutic properties for centuries. Pamukkale has also played an important role in human history. Ancient civilizations, particularly the Romans, recognized the healing benefits of its thermal waters and built bath complexes nearby. This connection between geology and culture adds layers of meaning to the site, making it a place where natural beauty and historical significance meet. Mauritius underwater waterfall. Some natural phenomena challenge what we think is possible, and the underwater waterfall off Mauritius is one of them. Despite its name, this waterfall isn't water cascading downward like those on land. Instead, it's an optical illusion caused by underwater currents moving sand and sediment over the edge of a steep continental shelf. As these particles shift and flow down a drop-off exceeding 2,000 feet, they create a visual effect that looks like a powerful waterfall plunging into the depths of the ocean. The contrast between the shallow, clear blue waters and the dark abyss below amplifies the illusion, especially when viewed from above. Aerial perspectives from planes or drones reveal this spectacular sight, making it appear almost unreal. The steep underwater canyon and the movement of sediment combine perfectly to create this dramatic display, drawing attention from scientists, photographers, and tourists alike. This natural optical effect highlights the complexity and variety of Earth's landscapes beneath the surface. It reminds us that the ocean, covering most of the planet, still holds remarkable features that can surprise even the most experienced observers. What seems like a simple waterfall on the ocean floor is actually a dynamic process involving geology, oceanography, and sediment transport. Giant's Causeway. Every visitor to Northern Ireland's coast encounters one of the world's most remarkable geological formations, the Giant's Causeway. This natural site is famous for its thousands of hexagonal basalt columns, tightly packed together and stretching out along the shoreline. The uniformity and precision of these columns make them appear almost engineered, yet they are entirely natural. Their origins trace back roughly 60 million years during a period of intense volcanic activity. As molten lava erupted and flowed, it began to cool and contract. This cooling process caused the solidifying lava to crack in a distinctive pattern, resulting in the mostly six-sided columns seen today. This process is similar to how mud dries and cracks, but on a vastly larger scale. The columns vary in height, some towering nearly 40 feet, creating a striking stepped formation that resembles a giant stone staircase. Local folklore adds to the site's allure, with stories of giants constructing the causeway as a bridge to Scotland. However, the scientific explanation reveals a spectacular volcanic event preserved in stone. The Giant's Causeway offers valuable insight into Earth's volcanic past and the powerful forces shaping its surface. When observing the perfectly shaped hexagons, one is reminded that nature's craftsmanship can surpass human-made structures.
Waitomo Glowworm Cave. Anytime you step into the Waitomo Glowworm Cave in New Zealand, you enter a world unlike any other. This cave is famous for its thousands of tiny glowworms that light up the dark interior with a soft blue-green glow. These bioluminescent larvae cling to the cave ceiling and walls, creating a natural starry sky underground. The glowworms use their light to attract prey, suspending sticky threads that catch insects in the darkness. The cave's constant humidity and darkness provide the ideal environment for these creatures to thrive. The cave itself is a product of millions of years of geological activity. Water slowly eroded the limestone, carving out winding tunnels, vast chambers, and flowing underground rivers. This process shaped a unique setting that perfectly complements the glowworm's light show. Together, the biology of the glowworms and the geology of the cave combine to create an extraordinary experience. Visitors are drawn not just to the glowworm's beauty, but also to the remarkable story of how such a cave was formed deep beneath the surface. Pink Lake. Some lakes stand out because of their unusual and vibrant colors, and pink lakes are among the most striking examples. These bodies of water display shades ranging from soft rose to deep magenta, a result of unique environmental conditions. The pink hue appears when salty water combines with specific microorganisms that thrive in extreme conditions. A crucial contributor to the color is a type of algae known as Dunaliella salina. This algae produces a red pigment to protect itself from the high salt concentration in the water. Alongside this, certain bacteria that also produce reddish pigments add to the effect. When salt levels rise, especially during hot, dry periods, these microorganisms multiply rapidly, turning the lake's waters a brilliant pink. The color of pink lakes can change throughout the year. Rainfall and shifts in water levels influence the concentration of salt and the population of the algae and bacteria, sometimes causing the pink shade to fade or disappear. This natural fluctuation creates a dynamic environment that continues to interest scientists studying the complex relationships between biology and geology. Badab-e-Sirte. When you explore Iran's landscape, Badab-e-Sirte stands out as a remarkable natural feature. This site is a series of terraced pools formed from mineral-rich hot springs, depositing layers of travertine over thousands of years. Extending over 5,577 feet, about 1.06 miles, along a hillside, these terraces are notable for their vivid orange and red colors, caused by a unique mix of minerals, especially iron and magnesium, present in the water. The terraces look like a stepped formation, each pool filled with warm, mineral-laden water that changes with the seasons. As the springs continue to flow, layers of carbonate minerals accumulate, slowly reshaping the pools and terraces. This process results in a dynamic landscape that shifts over time while maintaining its striking appearance. Scientists remain fascinated by Bata Cert because the exact conditions producing its distinct colors and forms are still being studied. The interplay between water chemistry and geological processes creates a rare natural display that continues to draw attention. This site highlights how mineral content and water movement can combine to produce geological formations unlike many others in the world. Tianzi Mountain. Just north of China's Hunan province lies Tianzi Mountain, a remarkable natural formation that captures attention with its towering quartz sandstone pillars. These columns rise sharply from the forested landscape, some standing over 1,200 feet tall. Their distinct shapes result from millions of years of erosion and weathering as wind, rain, and natural fractures slowly wore away the softer rock, leaving these impressive stone pillars standing isolated. The geological processes behind Tianzi Mountain offer insight into the long-term forces shaping Earth's surface. The pillars formed as a result of tectonic uplift combined with the gradual breakdown of sandstone. This combination created a landscape unlike almost anywhere else on the planet, where vertical columns dominate the terrain and create a dramatic, almost otherworldly scene. Tianzi Mountain's striking appearance has drawn attention beyond just geologists. Its unique formation served as inspiration for visual effects in films, highlighting how natural landscapes can influence culture and art. Yet, the scientific community continues to study how these pillars resisted erosion over time while surrounding material disappeared. Lençóis Maranhenses. What makes this landscape truly unique is the striking combination of vast white sand dunes and seasonal freshwater lagoons. Over extensive areas, strong winds constantly reshape the soft sand into rolling dunes that shift and change form. During the rainy season, heavy rainfall fills the low-lying areas between the dunes, creating bright blue lagoons that can last for several months. This ongoing cycle of dry dunes followed by temporary lagoons creates a rare environment where desert conditions meet water. The lagoons appear and disappear with the changing seasons, resulting in a dynamic, ever-evolving landscape. Scientists continue to study how the interaction between wind, rainfall, and sand sustains this unusual ecosystem. The mix of tropical climate and desert-like features makes the area fascinating for both geological and ecological research. The natural processes at work demonstrate how Earth's surface is continuously shaped by the interplay of weather and geological forces. The shifting dunes and transient lagoons highlight that landscapes are far from static. They evolve over time. This constant transformation offers valuable insights into how different natural elements combine to form unique environments. Chocolate Hills. One of the most unique natural landmarks in the Philippines is the Chocolate Hills, a vast area covered by over 1,200 cone-shaped mounds. These hills are coated with grass that changes color with the seasons, vibrant green during the rainy months and rich brown in the dry season, giving them the appearance of giant chocolate drops, which explains their sweet nickname. The formation of these hills dates back millions of years when the region was submerged under the sea. Layers of limestone, created from coral reefs and marine deposits, accumulated on the ocean floor. Tectonic forces then pushed this limestone upward, exposing it to weathering and erosion. Over time, rainwater and wind gradually wore down softer rock, leaving behind the harder limestone and rounded hill-like shapes. Scientists continue to explore how natural erosion processes produced such a uniform and expansive formation. Despite ongoing studies, the exact mechanisms behind their creation remain partially uncertain. Beyond their geological interest, the Chocolate Hills hold cultural significance and attract visitors from across the globe. They inspire local stories and stand as a striking example of how natural forces sculpt the Earth's surface into remarkable and unexpected landscapes. Thanks for watching. Which ancient geological wonder amazed you the most? Drop your thoughts below, and don't forget to like, subscribe, and hit the bell for more incredible natural mysteries.